That's the bell, yelling. Sorry for stealing your electricity. Whose school's electricity? Subject? What is this? Yeah. What? Dude, this one tuna. This one. Yesterday, and then say some coffee. I was just making me so hungry. Yo, what happened to shit? Oh. I gotta get those balls. We were testing a hypothesis. You were saying that when you walk in, you're going to say something. I'm trying to say something like that. Well, someone borrowed it and they didn't bring it back. Yes, he would, bro. I say it anytime. Expansion.
Yeah, that's what I was wondering, because he told us not to do it.
I know you're raised, man.
We're supposed to do 10 on number 24. No? Alright. You know how to do this?
I know you do.
How to do it on your end? No.
Not racist.
Alright.
How do you know what racist is? You know what genuine means? This is 30th, bro. When did you do that? This is 30th. When did you do that?
Monday.
Oh, okay, damn. Wait. Somebody do it. He's still about 8. Somebody help me.
Couple free points, but if you've not turned that in, please do it now.
You were supposed to have like 9 and 10 on that.
That's correct. You did not have to do 9 or 10. You don't know how to do it. That's late. And Luke.
It's like sticking out on the side.
Okay, last call. Any other 24s? Okay, so if you guys would look at assignment 26 so we can get started here. Most of our class this morning will be on practicing and getting a little bit better with chain rule that we talked about last time. So it takes more than one class to really get where you need to be with chain rule. So first thing we're going to look at is assignment 26, where I've got 4 questions. And these aren't from you, they were actually from last year, but these were the most missed chain rule Khan Academy questions from last year's group. So there's a good chance if they struggled with them their first go around, there's likely something to be on there about those that you could struggle with. But we'll go ahead and look at those 4 just kind of as a quick little refresher about what chain rule is and how to approach that. Then we'll spend most of the class doing a chain rule circuit, so that's number 27. So of course some of those will be easier than others, but hopefully feel more and more confident about chain rule as we go through that. And then for your homework / classwork, if you have chain rule down better and you can get to it, I'm giving you the test review early, so that's number 28. And I'm asking that you please do at least half of it before next class. It doesn't have to be the front half, just any half. That way that when I see you next time, because next time's your review, you'll have time to finish it, find the questions you need help with, and get help on those questions. And if you don't do some of that, number 28, then you won't know what I can help with. You won't know what you need help with in time. So, alright, so quickly, assignment 26, let's do a quick little refresh on what chain rule is and what the process is. So, question number 1, again, this isn't technically y'all, I just assumed that y'all's was very similar. But last year, when I pulled this up after those classes did them, only 1 out of 12 people got this one correct. So, remember with chain rule, that's when you have something plugged into something else. So this is like something cubed, and I'm plugging something into that. It's not just an x, it's something besides an x. So what we'll be doing today is we're going to use our same derivative stuff, power rule, once in a while product rule, once in a while quotient rule. In this case it would be power rule. Bring the power down and lower the power by 1. So that's the derivative of the outer part with the inner part plugged in. You just leave that alone. Now notice, do you see how one of the choices is this? One of the answer choices is this. That is almost always the case on chain rule type questions when you're taking the derivative. If you forget chain rule, that answer is still going to be there because that's the most common mistake. So you also have to come back, and I will try to do all of these in red. You've got to multiply by the derivative of that inside. So it's not that it shouldn't be hard for you to take the derivative of natural log of x because we just memorized that, but you have to train yourself every single time you take a derivative to consider chain rule. Every time for the rest of your calculus career. It's never going to go away. Okay, if we go down to question 2, so sometimes I think 2 is probably the hardest of these 4, even though 3 out of 15 people got this one right. But I would still recommend sometimes that you rewrite this a bit. So instead of saying this is the square root of e to the x, maybe just call it e to the x over 2. Because square roots are the same as exponents of a half. And then you can do the derivative of the whole thing. The derivative of e to something is going to be e to something. Just like e to the x is e to the x. But then you have to come back and say, let me multiply by the derivative of the inside part. So what I was plugging into e to something was x over 2. And I don't know why, but sometimes you guys struggle with this. X over 2 is the same thing as 1/2 x. So his derivative is a half, and that looks like choice B. Notice choice C would be correct, except that they don't have the chain rule step on there. As I said, that distractor is pretty much always there. Okay, on to question 3. So again, the way we talked about it in your notes, that's not really how I formulate it in my head, but take the derivative of the whole thing. The derivative of natural log of something is 1 over the something, and then just make sure you come back and multiply by the derivative of the something. The derivative of the inside part, you always have to do that. So, assuming you remember that, you end up with this, and you were finished. Notice choice D looks good, except it didn't do chain rule. Okay, and then last one for this, again, just a couple quick examples. How do we take the derivative of cosine something? Okay, negative sine of the something. Don't worry about how complicated the something is. So that means the answer to this is A? No, because you have to come back and multiply by the derivative of the inside. The answer is D. So I know I emphasized this last class, but as we move on to the circuit now, it's important that you understand chain rule is not different type of differentiation. It's an additional step. You still do power rule, and then maybe you do chain rule if the derivative of the inside's not 1. Sometimes you undo one you memorize, and if the derivative of the inside's not 1, you need to multiply by the derivative of the inside. I don't know. Those two are just memorization ones too. So, but chain rule is just an additional step. It's not in place of power rule. It's possibly after power rule. It's not in place of product or quotient rule. It's after product or quotient rule. Okay, so this is our third circuit. So again, just a little bit different than me just giving you 20 question worksheet and say just do them and check them all. So you guys understand the directions now. Obviously start with question 1. I want you to try to take the derivative of this. Of course, think of chain rule. This whole worksheet is trying to get you to try chain rule on every single question. And that answer should tell you where question 2 is. So go ahead and start here, please. And then every 2 or 3 minutes, I will share an answer with you and offer to work and help out. And then I'll grade these homeworks while you guys are getting a head start. Does anybody need more time for question 1? Again, I don't mind working out as many of these as we have time for, but what I got for question 1 was 10x times x squared plus 7 to the 4th. Everybody agree with that for question 1? Anybody want me to work out question 1 for you? Now, of course, I didn't really say anything new about chain rule today, so I'm not asking you to really learn chain rule. We did that last time. It's not hard to learn what the step is, but of course these questions vary quite a bit in difficulty. So, question 2. I ended up with 5x over x squared plus the square root of x squared plus 7. Now, if you haven't had time to finish question 2, that's fine. That's one thing. You can still ask later. But has anyone tried question 2 and not ended up with this as an answer and need to see it worked out? Yes. Okay, so your choice or not, if you want to do the 5 as part of your derivative or just pull 5 out and deal with it later. That's the constant multiple rule. I tend to always pull it out and worry about it later. Then to take the derivative of this stuff, you probably want to think of this as x squared plus 7 to the 1/2. So the first derivative rule you have to do is power rule. You have to bring the power down, lower the power by 1, and then remember to come back and multiply, I'll do in purple, times the derivative of the inside. And the derivative of x squared plus 7 is 2x. And then to simplify to this, times 2 divided by 2, cancel out and go to 1. And then the only thing you can do to simplify is to say 5 times 1 times x is 5x. And this stuff to the negative 1/2 could move to the denominator and become to the positive 1/2. And I change positive 1/2 back to the square root. So multiplying by 2x was a chain rule step. Otherwise it was just power rule. Okay, is that enough for number 2? Okay, then that means number 3 is here. And my answer for 3 was 2x cosine of x squared plus 7. So again, if you haven't gotten to 3, if you haven't finished 3, don't ask for it yet. You need to try it on your own first. But did anybody try 3 and get stuck or not get this as an answer? Obviously, we're going to continue piling on this. So if you are having a mistake with question 3, then it's better to clear it up now before the questions get a little bit longer. Okay, let me give you a little bit more work time then before I offer to help out some more. Another chance for me to work out questions 1, 2, or 3. Anybody change your mind on seeing those worked out? Okay, then my answer for question 4 would be a 3 times an x times the square root of x squared plus 7. Anybody ready to see that worked out? Okay, I'll share one more. Again, I know some of you are probably quite a bit past that and some of you aren't, so I'm just trying to be somewhere in the middle here. Just from experience, I can tell question 5 is probably going to be one of the more missed ones. But question 5, I ended up with a 4 times an x times a sine of x squared times a cosine of x squared.
Can you work that one out?
Yes, I will. Is everybody to at least question 5? Has everybody gotten to this one and at least tried it? Okay, the reason why I suspected this one to be more missed than maybe the first few is because the way we use exponents on trig functions. This means the same thing as I have sine of x squared squared. It's just with trig functions, this is how we write it. I think we don't do it like this. We don't put it on the outside because then you don't know if you're squaring this or you squaring this. Obviously, if we put parentheses, you would know. But these two things say the same thing, so make sure that you're aware of that. I even have that up here on the board over here with cosine. Cosine to the 9th power is the same thing as cosine to the 9th power, just we write it funny with trig functions. So for this question, you should have started off with power rule. Bring the power down, lower the power by 1. Don't worry about how messy that inside is. You're just taking the derivative of the outside with the inside plugged into it. Then you have to come back and say there was an inside, so let me take the derivative of that. And what's the derivative of sine something? Okay, so cosine of the something. And this is still not what I got. And now this would be totally fair that you didn't think of this because this didn't come up the first time we talked about it. So what have I not done here? What do you think I need to continue to do? Okay, but well, you see the answer here, so you know to multiply by 2x, but why? It's the derivative of the inside. You can have more than one inside. If you have 5 insides, I guess in theory you might do the chain rule 5 times. In this case, there was 2 insides. The first time I brought the power down, lowered the power by 1, and this stuff underlined in red was the inside. So I did the derivative of it. But when I took the derivative of this red part, there was an inside, so you have to do chain rule a second time. You have to do chain rule as many times as many insides as you have. So the first inside was sine of x squared, the second inside was just x squared. So not that that's super common, but sometimes you will need to do chain rule more than once. So again, that's totally, that didn't come up at all the first time, so I can totally see why you wouldn't have thought of that. But I think there's at least one more question on today's worksheet where you have to do chain rule more than once. Okay, did anybody have anything specific about 5 to ask about now that you've seen it? Okay, go ahead, keep going. Also, like we've been doing on the circuits, if you get stuck on one, don't give up instantly. You need to try to persevere. But after a minute or two, just work a different random question. That way you're still being productive, and then when you get to that part of the circuit, you can just skip that question because you'll have it done. So, again, I will offer to help out with as many as we get to. So.
May I go use the restroom?
Yeah. PLC.
And then you have the board?
Yes, please. Yeah. Here's the. here to offer a couple more. So question 6, I got 4x squared plus 14 over the square root of x squared plus 7. So if I remember right from yesterday, I think the next couple tended to be pretty highly asked. So somebody wants to see number 6?
Yeah.
Okay, so if you need number 6, go ahead, follow with me. If you got that and you're good, then you can just keep on going. Okay, so what's going to be a pain about number 6, and what's going to make it a little bit harder to get that as an answer, it's not that power rule, product rule, quotient rule, or chain rule get any harder, but if the questions get longer, it's harder to do more steps without a mistake. So first off, I'm going to deal with this 2 later. Again, that's the constant multiple rule. And that leaves an x times a square root of x squared plus 7. I've got something in terms of x times something in terms of x. That means my only option is to do the product rule here. Chain rule is not a replacement for product rule. Chain rule comes sometimes within product rule. So I'm going to take the derivative of x, which would just be 1, times the second part left alone, plus, now I'll leave x alone and take the derivative of this part. Now this, you might want to, it's never a bad idea to kind of go over to the side. So to take the derivative of this second part, you'd have to do power rule, bring the power down, lower the power by 1. Okay, and is there anything else there? Right, there's an inside to that. I just took the derivative of this. It's not the square root of x, it's the square root of some other stuff. So we need to come back and multiply by the derivative of that other stuff, which is 2x. So that I have highlighted is the only chain rule step within this question. Okay, now we just need to simplify it till we can get our answer to look like that. So we can do something like times 2 divided by 2 cancels. We could distribute this 2 back in. Over here I've got an x times an x. This stuff has a negative exponent, so I'm going to move it back to the denominator. I almost forgot to distribute the 2 back. Make sure you distribute this 2 if you're going to pull it out at the beginning. You don't have to pull it out at the beginning, by the way. You can do it within product rule. You can treat this as 2x, and so this would have been 2 instead of a 1, and this would have been a 2x instead of an x. So it all balances out. But this is technically the derivative, and sometimes that's fine. If this was a free response question or a fill-in-the-blank type of question on your test, if I ask for the derivative, that's the derivative. But as a multiple choice question, which is a lot of what we do, because that's how your AP exam is, they're going to try to simplify this more. And so when I did this circuit, again, I've done this one for years, of course, but I always try to do them again a few days before our class. I start looking at the answer choices. None of them look like that. So one of the most common ways to simplify further is common denominators. So if we multiply the top and the bottom of this by the square root of x squared plus 7, of course you have to multiply top and the bottom, so that's like you're multiplying by 1. But the purpose of that is to get a common denominator, so you can shove all of that together with that common denominator. This is plus 2x squared at the end. And over here, this is a 2 times, okay, this goes with this. What's the square root of x squared plus 7 times the square root of x squared plus 7? Okay, x squared plus 7. And then if you're willing to combine like terms here, I've got 2x squareds. 2x squareds could combine to 4x squareds. 2 times 7 is 14. And now that they have that common denominator and I can write them together, that's how they came up with that. So, again, it's not often you have to do chain rule within product rule, but that's basically what this question was. It was a product rule question with one time of considering chain rule that I have highlighted. Okay. Is that enough? Yeah.
I'm a little confused on how you recognize when to use chain rule. Like, what's like the most?
Because there's an inside that does not have a derivative of 1. So if this was just square root of x, you just do the power and lower the power by 1. But the derivative of x is 1, so if you want to say times 1, go for it. But if it's the derivative of some other stuff that doesn't have a derivative of 1, you have to multiply by its derivative. Every time. So honestly, the shortest or most efficient thing you can do is just assume you're going to, every time you take a derivative of something, not if you're leaving something alone, like right here, I left this alone. I wasn't taking this derivative, so I didn't need to think about chain rule. But over here, when I was taking the derivative, every time you take the derivative, you need to just assume you're going to use chain rule. Okay, and then, okay, was there others to this? Okay, then let me share one more, and then I will give you a little more time. Okay, I think that was number 6, so this would be 7. And for 7, well, I'm not going to give you any hints here, but I ended up with negative cosecant x times cosecant squared x plus cotangent squared x. So I will offer to help out with that one in a few minutes, but I don't think everyone's had time to give that one a shot. So. Okay, has anybody not tried question 7 yet? Because I can give you more time if you need. Okay, so maybe I should have saved the video yesterday, but on question 7, when I did this for, I think, my second period class, I started off with the quotient rule. I've got something divided by something, so I started with the quotient rule. And I got an answer that was correct, but it looked nothing like anything on this worksheet. So, even though my answer was equivalent to the answer that was on the worksheet, it was too far off for me to see that it was equal to this. And so, occasionally, sometimes you can do things perfectly right, and as multiple choice, it could just look totally different. So I came back and I said, well, what if I try a different way? Maybe they worked it a different way. And so what I'm going to do is I'm going to split this up. This is sine squared, which is like sine times sine. And I've got one cosine. So I'll do a cosine times 1 gives me cosine. The reason I thought to do it this way is because cosine over sine is cotangent. 1 over sine is cosecant. And now notice this is still y equals, I haven't done any calculus yet. But if you have your trig derivatives memorized, you don't even need chain rule for this question. You want the derivative of something times something. So you had to do product rule if you did it my way, which I'm guessing is their way because it made the answer match up nicely. So if you've not memorized these trig derivatives, just make sure you do it before the test. It is on the test review reminding you what they are and that you need to memorize them. But the derivative of cotangent is negative cosecant squared times a cosecant left alone, plus, then leave the cotangent alone, times the derivative of cosecant, which is negative cosecant cotangent. And then if you look at this term and this term, they both have a negative cosecant x that you could factor out. And then after you factor it out, the leftover stuff makes it look just like their answer. So that's kind of frustrating. I mean, I feel the same way. I spent a good 5 minutes or so doing quotient rule. Again, my answer was fine, but my answer looks so far different than how they did it and what their answer looked like that honestly my best strategy was to just erase everything, start over, and just think of a different way to try the question. So, but I guess the nice thing about taking this approach is I didn't even need chain rule at all this way. Okay, does anybody have anything specific about 7 you'd like to ask? Okay, I'll share one more answer with you for now. And I guess if everyone's tried 8, we can go over it if you need to, but that's what I got for 8. Okay, anybody need me to tell you where that answer came from? Yes?
Yeah.
Okay. So, I'm going to say the majority of the challenge on this question is just memorizing the trig derivative. What's the derivative of secant something? Okay, secant something times tangent something. And notice, that's almost the whole thing. But since there was an inside to this question that did not have a derivative of 1, you're taking the derivative of this, now we have to follow up and take the derivative of the inside, which would be times 2x. So you had to memorize the derivative of secant, and then remember the chain rule and be able to take the derivative of x squared plus f. Is that enough? Okay, I will also share my answer to 9, and I will warn you guys, I think 9 is probably the longest question, which of course makes it the hardest question too. And I am sure we'll need to work this one out. But I'm going to give y'all a little bit of time to try to see if you can get it on your own first. That's what 9 should end up looking like. After many steps and many simplifying steps. So, if you get stuck, just work on another question for a few minutes. Let's give everybody time to try it and see how close they can get. Of course, there's a lot of value, even if you can't get to that, getting as far as you can, realizing where you got stumped is still really good information for you. It still teaches you that step that was holding you back, whatever it is. Okay, I'm going to assume you're moved on or stuck on this one. So if you did get stuck, let's make sure that you see what you should have done differently or see where you went down the wrong path here. Okay, so first off, the most important part here is realizing why you have to do product rule. We've got something in terms of x times something in terms of x. So if we can't combine all of this stuff together with algebra or fractions or exponent rules or something like that, your only option is product rule. Bless you. So first I'm just going to take the derivative and not worry about simplifying it all. After I have the derivative, I will simplify, simplify, simplify until I get it to look like one of their answers. So cube root is like an exponent of a third. So I did power rule, bring the power down, and lowered the power by 1. Since there was an inside to that question that I took the derivative of, I have to multiply by the derivative of the inside. So that highlighted step is chain rule, times the second part left alone, cosine, plus, now I'll take the derivative of cosine, which would be negative sine, changes that plus to a minus, times this part left alone, okay, so again, technically that is the correct derivative, and sometimes that's perfectly fine. But in this question, there was several different things that you could do, and I don't know why they did the last couple steps, but they did. So let's go ahead and move forward until we get it to look like that. So first off, if I'm looking at this big term here on the left and trying to combine all of this stuff, I've got a 2 times an x times a cosine x, 2x cosine x, over, I've got a 3 in the denominator, and I'm going to move all of this stuff to the denominator also. Since it had a negative exponent, negative exponents are never considered simplifying math, so I know they're going to make that positive. Minus, minus, okay, I can't really do anything with this over here. So once again, I started looking at the answer choices. I hope that the answer stopped here because I don't want to have to do more than I need to, but none of the answers look like this. So like a few questions ago, the next thing they did was get a common denominator. Between 1 and 3 times this stuff, it's going to be 3 times this stuff. So multiply the denominator by that, so they have a common denominator, and then multiply the numerator as well, so it's like you're multiplying by 1 and not changing the size. I'm going to have to dip down into this to be able to finish this, but the purpose of getting a common denominator is now we can shove all of this together as one big fraction. And we've got a 2x cosine x here, minus, again, I'm going to try to simplify this as much as possible. I've got a 3, I've got a sine x, but x squared plus 7 to the 1/3 times x squared plus 7 to the 2/3. What did those two combine to? Right, x squared plus 7 to the 3/3. When you multiply things with the same base, you add the exponents. And 3/3 is the same thing as 1. So all of that just becomes x squared plus 7 to the first, or 3/3, whatever you want to call it. Now, I think changing this exponent to positive is pretty much an always. Getting a common denominator, pretty common also. The last 2 steps I think on this question, I have no idea why they wanted to do that, but sometimes you just got to do that. And that is they distributed. So they took 3 sine x times this stuff. Now I almost missed this yesterday because I tend to think this is sine of this stuff, but it's not. It's sine of x times that stuff. So you can distribute negative 3 sine x times x squared and negative 3 sine x times 7. And then the last step, again, I have no idea why they chose to do it, but let me zoom in here. The last step is they just went back and said, let's divide everything by 3. So that made this 2/3 x cosine x minus these 3's just canceled, x squared sine x. These reduce to -7. And then when these 3's cancel, that's how they eventually got to that. Now again, I have no idea, no rhyme or reason why they decided to divide everything by 3. But I just knew that I had to keep trying something because it wasn't matched up that way any beforehand.
Okay, let me update this real quick.
Okay, so there was a lot to that question. Is there any of those steps you want me to say again, or any of the steps you want to ask something about? Okay. So again, I think it gets quite a bit easier after that, but it also just gets different. What I mean by that is you can see now they're wanting you to do chain rule, where you have to figure out which part of this table you need to use. So it's going to be a whole lot less work than question 9, but you need to see if you can come up with -4 as an answer. Okay, so I feel a little more comfortable with this question type than maybe you do, but last time I saw you guys and you did those Khan Academies, one of the hints I gave you specifically for these table type questions is to write out, it's not really a formula, but maybe write out how you take the derivative of a function that's being plugged into the derivative of another function, which of course is what we call chain rule. So you can either just remember that formula, and I think it will help you in these question types, because most of this stuff is just distractors. You don't need most of these numbers. But the thing that's a formula is really the same thing that we do every single time for chain rule. You take the derivative of the outer with the inner plugged in times the derivative of the inner. And so if you want to know the derivative at 2, everywhere there's an x, plug in a 2, and then it's telling you where to find all this information. So I'm going to take the derivative of f at g of 2. G of 2 is -1 times g prime of 2. G prime at 2 is 3. And then I need to take f prime of -1, which is -4/3, times it by that 3, and that's where the answer becomes -4. So, in all those 12 values of that table, we really only needed 3 of them. So, honestly, probably what's best is for you to memorize the chain rule in this form. But again, it's the same thing that we do all the other times. That's why I tried to phrase it that way. Derivative of the outside with the inside plugged in times the derivative of the inside. Make yourself write that out, change the x's to 2, and then it's a lot more obvious what numbers you need to be plugging in where. And you can see the one next to the right of it looks very similar. So maybe that'll go a little bit better. My answer to 11's 21.
or anything, dude?
Not really, no, but it still makes no sense to me.
Yeah. Did he say when it's testing?
Monday, we got a review guide that we're gonna do on Friday.
Thank God it's not Friday.
And he said he like half the review guide by Friday.
Gosh, this is everything we learned so far.
All right, did anybody need to see 11 worked out? Yes, okay. So the derivative part is just going to be power rule, bring the power down, lower the power by 1, and then chain rule, come back and multiply by the derivative of the inside. Now, one really nice thing about this question is, unlike several of the others, if you want to do step after step after step after step after step of simplifying, if you want to, go for it. But it's completely unnecessary on this question because you really only care where the derivative is 1 anyway. So, once you get the derivative, whether it looks like this or you simplify it some, you're just going to be plugging in 1 everywhere there is a t. And you get 21 times 1 times negative 1 to the 6th, which ends up being 21. So what you're going to find out is that derivative questions where you need to plug in a number at the end, well, first your answer should just be a number. It shouldn't be in terms of x, it should just be a numerical answer. But those are typically a little easier to work with because no matter how crazy messy your derivative is, just plug the number in, do the arithmetic, and you don't have to do the simplifying like some of the harder other questions. Okay, does anybody have anything specific about number 11 while it's still up there? Okay, then for question 12, I ended up with -2. Yeah.
For this one, would it be wrong if I did like 1? Sorry. And then just the rest of it? I mean, not the 1, but just turned into cotangent.
Yes.
Okay.
Okay, does anybody need to see 12 worked out? Okay. So just based on, you want to know something about the derivative of f, and this is how f is defined. F is g plugged into h. Well, that's the first thing I did, is I just went ahead and plugged a g into h and said f looks like this. That's the function g plugged into h, square root of x. And then I just looked at this to go forward. Start off by doing power rule. Bring the power down. Lower the power by 1. And then chain rule. Make sure you take the derivative of the stuff inside and multiply it. So times 6x minus 6. Now again, there's lots of simplifying you could do here. You could factor out a 6. That could cancel out what the half. Do it if you feel like. But for this particular question, you're just plugging in -1 anyway. So I tend to not simplify very much on those questions. I just plug it in. If I plug in a -1 there, that's 3 plus a 6 to the -1/2 times -6 minus 6, which would be -12. Let's see, this would be 9. 9 to the 1/2 would be the square root of 9, which would be 3. But since it's -1/2, that would put it down in the denominator. And so you end up with -12 over 6, which is -2. So obviously I'm going through the arithmetic pretty quickly, but I just plugged in -1 everywhere. There was an x in my derivative, and squared and multiplied and all of that kind of stuff. Okay, I'll leave that up for a second to make sure you don't have any follow-up to it. Then we'll share number 13. Okay. I think 13 was a little bit easier, at least easier than some of them. But 13 should come out to be -2/9. We need to work this one. Yes? Okay. So the most important part for this is to even start. Now again, it's fine today, it's fine next class, but the class after that, you need to have all 6 trig derivatives memorized. The derivative of cosecant something is negative cosecant something cotangent something. And the thing that we are trying to hammer into your brain here is times the derivative of the inside. Now again, x over 3 is the same thing as 1/3 x. I don't know why y'all have trouble telling me what the derivative of x over 3 is, but the derivative of 1/3 x is 1/3. So again, anybody can memorize the derivative given enough time. But did you remember to come back and multiply by the derivative of the inside times 1/3? Okay. I guess one thing that is kind of tough about this question though is unit circle. You guys have to know unit circle. There's just no way around that, unfortunately. So cosecant at pi over 3 is the reciprocal of sine at pi over 3. Sine at pi over 3 is square root of 3 over 2. So this is 2 over square root of 3. Cotangent at pi over 3 is the reciprocal of tangent at pi over 3. You guys have that on your desk right now. It's square root of 3. So the reciprocal of that is square root of 3 over 3. The square root of 3 over 3's cancel out. Multiply across the top, you get -2. Multiply across the bottom, you get 9. So I guess it can be a pretty challenging question if you don't remember unit circle, but you have to review that if you've forgotten it. And as we talked about at the start of the class, if this was a test question that was multiple choice, one of your answers would be -2/3, because it would be testing to see if you remembered this times 1/3. -2/3 is not correct. -2/9 is correct. You could probably guess which one's going to be the answer to number 14, because there's only one that even looks remotely similar to what you're starting with. But that's the answer I got for that one. Now we will run out of time here. As I said, we'd go over the ones we had time for. Okay, looking at our class website, I do have this one worked out for you as a video, so if you get stuck on it, you can watch that for help just from my other classes. And then if you did not work ahead, obviously you've got a couple more questions, but as you do these, they should get easier because you've got less answers to pick from, so sometimes when you get stuck, that gives you a hint on what you need to do next. Or you can come see me during advisory tomorrow, would be fine as well. But with our last 7 minutes here, I'll remind you that you need to finish this up finish up the circuit, and then start working on the test review. So I'm asking that you do any half of the test review, just so that you have identified some of the easier stuff to you, have some of it done, and then when I see you on Friday, you'll have that class to finish up the other half, / ask for help on the questions you didn't know how to do, / start memorizing these trig derivatives, and then the class after that, we will have our second test. So, any questions about what you need to do from now till Friday? Okay, and then I think if you're interested in the puzzle of the day, I think this is the one you're on. You've not seen this one? Okay. So if you want to give that a shot, I'll leave that up until you're dismissed. And if you'd rather keep working on your test review or your circuit, that's obviously good too.